All right, everybody. This is the second part of the 7.3 notes, in which we are solving, basically solving higher order polynomials and higher degree polynomials. So where we last left off, so basically from the last video, this is just kind of a continuation. We kind of left off on the last. I'm just kind of moving on with some of the examples here. So for this one, so f of x is equal to 3x cubed plus 19x squared plus 4x minus 12, all right? So let's remember our steps here. So again, number one, I'm going to do possible zeros list, all right? Again, what I do for that, that's essentially my factors of p divided by my factors of q. Now again, p, my last number here, right? So that's so factors of 12, which is going to be plus or minus 1, plus or minus 12, plus or minus 2, plus or minus 6, plus or minus 3, and then plus or minus 4, and that is it, all right? And for q, my first number here is the 3, all right? And the only numbers that really multiply to 3 are plus or minus 1, plus or minus 3. Again, factors, I'm trying to find numbers that multiply to this last number and multiply to this first number here, all right? And then what I do with this is I'm just going to divide, all right? I'm going to divide this first list here by all these numbers down here. Divide this whole list by 1, I'm literally just going to rewrite the list, all right? So I'm going to have a list. I have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12, and then plus or minus, oh, that's actually it, sorry. Let's see, 1, 3, 4, 2, 6, 12. All right, so yeah, that's good. All right. So now what's going to, so, and then now I divide this all by 3. Let's see, 1 divided by 3, that's going to give me 1 over 3. 2 over 3, 12 divided by 3 is 4, so I don't have to write it. 2 over 3 is, just 2 over 3, so plus or minus 2 over 3. 6 over 3 is 2. 3 over 3 is 1. 4 over 3 is, well, a new number, so 4 over 3, all right? All right, so that's my first step. Second one, use synthetic division. Synthetic division to confirm, all right? We're going to use this equation right here. We're going to synthetically divide that one by all of our possible zeros. Well, you could do that or check graphing calculator, all right? Oh, went a little bit too far. All right, I'm going to pause the video real quick, and I'm going to transition over to the graphing calculator. All right, so I've gotten to my graphing calculator. I've plugged in my 0. This is my slicer right here. And I've plugged in my equation here into my graphing calculator. Oh, I'm going to actually have to rewrite some of that. And what I find is that I have a 0 of -6, -1, and then 0.667. All right, so we'll kind of focus on these ones here, the -6 and the -1. And I unfortunately erased my list of zeros, which I'll kind of write out again, but all of those zeros, the -6, -1, and the 6.667, those are actually on this list, all right? So what I'm going to do now is I'm going to pick x equals -6 as one of them. Now I'm going to synthetically divide the equation by -6. So -6 in Sayer, 3, 19, 4, and -12. And then I synthetically divide, bring the 3 down, multiply those out. I get -18. I get -6. Bring a 2 down. Then I get, hold up here. Oh, that should be -2, excuse me. And then that should be 12. Then I get 0. All right. I'm going to write a new equation here, which is 3x squared plus x minus 2. That's my new equation there. And all right, so from there, actually keep it this time. So from there, I check my other 0. I had -6, confirm that that's good. Now I go on to -1. All right, so I'm going to go back here in the slideshow. I confirm that one. and then I have x equals -1. Now I got to confirm this one. I'm going to synthetically divide using this new equation. So I'm going to bring this down here. Synthetically divide. I got a -1 there, and then 3, 1, and then -2. All right. Synthetically divide that. Bring the 3 down. Get 3. 3 times -1 is -3. Add those together. I get -2. -2 times -1 is 2. Get a remainder of 0. Again, that's what I want to see. If I'm not seeing that, then it's either not an x, then it's either not a 0, or double check your math. All right. I should get another new equation. I synthetically divided with an x squared. My new equation is going to have an x. This 3 is the coefficient, so it's going to be 3x minus 2. All right. Now, what I can do is I can now use what I did kind of in the last example. I take this last equation, set it equal to 0, and solve. All right. I'm just going to add the 2 over. Get 3x equals 2. X equals 2/3. All right. And if I look back on my graphing calculator, keep that. 6.667, that's essentially the decimal version of 2/3. So I have now confirmed my 3 zeros here, all right? Confirm my 3 zeros. Okay, so I got one more example in this set of notes that I'm going to go over. I'm going to kind of pause the video and get that example set up, and then we will work through it. All right, so I got this second example set up here. Hold up. There we go. So I got the second example up here. So finding all the zeros of x cubed plus 5x squared plus 12x plus 18. This is technically skipping, I think, an example in your notes. I think this is the only other example I'm going to work out in your notes. I didn't work them all out. But with this, again, I'm just going to set up first off my list, all right? P and Q. P, my last number here is 18. Q, my first number is 1. List out numbers that multiply to 18. I got plus or minus 1, plus or minus 2, plus or minus, 3, plus or minus 6. 3 times 6 is 18. 2 times 9 is 18. So I'm putting 9 out there. 1 times 18 is 18. So that's my list of P right there. And then Q. Well, number that multiplies to 1 is literally just 1. All right? So when I divide all these numbers by 1, well, I'm literally just going to rewrite my list out. It's going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and then plus or minus 18. All right? Okay, so for the last two problems, we've seen 3 definitive x-intercepts, which basically means we had 3 real, y-intercepts, or we had 3 real solutions. But what would happen this time? What would happen if I just had the 1 x-intercept here? So I took the equation that I had here, and I went ahead and graphed it onto Desmos here. And, well, right now I only have this 1 x-intercept, -3, which shows up on my list right there. The negative shows up as -3. But if I go back here, I see that I'm not going to cross the x-axis anymore. So that's really the only 0 I can work with to synthetically divide. Okay, so let's go ahead and use it. All right. So I got x equals -3. All right. I'm going to synthetically divide by -3. I got a 1, then a 5, then a 12, then an 18. All right. Synthetically divide, get the 1 down here, multiply that, get -3. Add that, get 2. Multiply that, get -6. Add that, get 6. Multiply that, get -18. Look at that. I got 0. All right. I write out my new equation, which again, start off with the x squared, and then these are just your coefficients, and the last one's your constant, so plus 2x. No more x's to deal with, so just 6, so that's my new equation there. All right. So now what I need to do is I don't have any more x-intercepts to work with, all right? I've confirmed that that one is right, but I don't have any more x-intercepts to work with. So now what I need to do is I need to now take this equation, kind of like what I did with the last equation that I was working with, this new equation, and I just need to solve that one, all right? Now if we notice, x squared, that's a quadratic. So now I have to utilize my quadratic methods in order to solve this. And what I'm going to do is I'm going to use quadratic formula, all right? So I'm just going to plug this in to quadratic formula. So if we do on the top, we got plus or minus, so we start up with negative b, negative 2, plus or minus b squared. Again, this is a, this is b, this is c. Minus 4 times what the number out front is 1 times 6. All over 2 times 1. If I'm gonna take this here and simplify it out. 2 squared, which is the same as 4. Minus 4 times 1 times 6, which is the same as negative 4 times 6, which is minus 24. 4 minus 24 is negative 20. I'm gonna put that back underneath the square root. Bring it over here, plus or minus square root of 20. 2 times 1 is 2. And then what I see here is that negative, I have a negative there, so I have to bring out an I. So I have negative 2 plus or minus I times the square root of 20 over 2. And then the last thing I do is I want to break down my square root using kind of like what we did, using breaking it down methods. So I have a perfect square of 4 that goes into 20. So 4, square root of 4 times square root of 5. That turns into square root of 2 times square root of 5. I still have that I, so I'm just going to kind of write that I right there next to it. Plus or minus negative 2 divided by 2. Then the last thing I do is I take all 3 of these numbers here and divide by 2. So I'm left with negative 1 plus or minus 1 or just I square root of 5. All right. And now with this plus or minus, that gives me 2 solutions. This is already 1, so I have 3 total solutions, which is what I want. Oh, which again, that's what I want. All right, I want 3 total solutions. All right. Okay, so that's basically the last example that I'll work out there. I also might work out a couple homework examples from your homework. This is just from the notes. Again, if you guys have any questions over this stuff, just please make sure you are reaching out, letting me know. I know this stuff might be a little bit much, but just make sure you are keeping on top of it and asking questions when you need. Thank you guys for listening, and I'll see you in the next video.